Okay. And so here we go. We're going to go through these more advanced concepts for vector design and making. The same laser and vinyl cutter and waterjet cutter skills, but like where this can go and how you can process it in different ways. So I would classify these as more the advanced concepts and advanced ideas. Once you've been able to turn on the machine, get it to run, even if it's not completely consistently, but you're like getting there and you can get it to run some of the time. These are the ideas that it's good to start to think about when you want to go a little bit deeper on how to use the machines. And we'll be able to unpack some of these a little bit further as we get going. We're going to start with sort of design and art ideas that are interesting when put in the perspective of these machines. And then we're going to go more into sort of the logistics of how the machines work, and then finally end with Dxfs, which is a nod to 3D design, which we're going to get to in not too long, in like 2-3 more weeks. So first off, let's talk about islands, which sound lovely right now in the midst of winter as we wait for the new year. But islands are an important thing to think about when you're doing your design work. And by island, I mean specifically a piece that is isolated, like in the word normal up here, an island would be like the inside of the O. So there's a lot of cases where you do design work and you have designs where there's pieces that are isolated from each other. And when you're just displaying them on a screen, it's not a problem at all. But if you want to make a spray paint template so that you can put up a sign that says fight racism, like this one over here, then you're going to need to make cuts in such a way that when you cut it up, it has all the pieces still there and none of them fall apart, which may feel like oh, no problem at first pass, but it actually can be a little bit more complicated than you'd originally expect. Like, for the sake of this, you can tell that their font choice is completely a stencil font, right? And text is probably the hardest part to think about when you're doing this in a design. But when you're laser cutting or waterjet cutting, you'll need to think about islands that you have. The normal fonts don't really do anything to factor it out, but a stencil font has those little connections. And there's a whole bunch of stencil fonts, like it's a whole category. I think that Microsoft and Apple both load one stencil font into their like suite of fonts that you get. But it's a whole category. Anything where you've got these little connecting bridges that keep like the inside of the E or the inside of an O from falling out, or like here the G in fight is connected at the top and the bottom, even though it probably strictly wouldn't need to. It's just stabilizing it so that if that was a piece of like thin floppy cardboard, you can imagine someone running around with a spray paint can and a piece of cardboard. They don't want the letters to fall apart just because they're running around trying to keep from being seen. So, and not that I'm encouraging, spray painting anything. Let's be very clear here. This is decorative art purposes. But with that, as you're imagining your designs, you want to choose designs in such a way so that your islands are planned for. Like if you look a long time at the face in this particular design, no part of the face is isolated where it would fall off. The thing that gets closest is like the teeth inside the mouth, but even that is connected by this little bridge over here on the side of the lip. And so it's a really interesting factor to take into your designs and how you particularly design something for one of these cutting processes, which is completely different from, I mean, you'd probably just close the mouth, define the lips a little bit better, and like have a different look if you knew that your piece was just going to be displayed on a screen. You have to make some different choices when you're going to be cutting it. And so stencil fonts are a big deal, but also if you want the opposite, like if you want, instead of keeping the letters or removing the letters, you may want to keep the exact opposite. And then cursive can do a really nice job of keeping the text and letting the spaces fall out because all the letters are connected together. Maybe this isn't the best cursive font, but you can imagine like a cursive stripe like we might have been taught in elementary school where all the letters are connected together. And so they would be supporting each other. And so if you laser cut away all of the other stuff, then it'll fall out and you'll have just the cursive left over. It's a really good trick for laser cutting letters, especially, is to do it in handwritten script. I've got a friend with an Etsy store, and that's basically what she does. She asks people to send them Sharpied messages in cursive, and then she can laser cut them because basically it's just Illustrator Live Trace, laser cut it, and send it back to them, which is a great service. But it's a clever trick to like, she's planning ahead for the anti-stencil and she can just connect the letters if they happen to come in separated. But it's totally a thing. You'll need to think about this probably more for the laser or the Waterjet, but it's good to look at. Another key design element that sort of ties in with that is positive and negative space. Just because I absolutely love this concept, and I taught at a school where there were elementary kids every so often. And so they talk a lot about tessellations and positive and negative space in art, which can be really helpful when you're doing specifically things on the vinyl or the laser cutter. Because you might make a design like the two faces or the vase up here, where when you look at the vase, it's the white part, and two faces if you can look at the black part. Some people are really good at flipping back and forth between the two of those, and it's good contrast. It's like a good psychology trick. You might remember the blue dress or the blue and gold dress debacle from a couple years ago. Is that kind of a deal. Down here across the bottom, these are more tessellations or patterns where you've got sort of the positive space and the negative space that can compete together. They can have interesting impacts from that. And so when you're thinking about laser cutting or vinyl cutter, and perhaps this is more a vinyl cutter thing, to think about the positive and negative space of what you're working with so that you're imagining the material being removed or placed where you want it to be. It can be a really helpful design piece. So I took the MakeHaven logo and just did an inversion, which was not effortless. This is a complicated thing to do where you get the exact negative of the vectors. I put in a square, cut it, and then like used it to chop the text, and then inverted all the colors of that. But it's really neat. And you look at it and you think there's a square, but in a very real sense, the vectors for this at no point include a square, right? It's sort of a squarish thing that's got the cutout for the letters, and your brain connects those dots to make a square. It's kind of a fun thing to do. And for tessellations, if you really want some good inspiration, Islamic art or from a mosque is some really, really good tile work if you wanted to get a look at repeating patterns and to see how that fits together. Or MC Escher if you're looking for the more Western world for what that is. So there's tons of interesting options for where to look at for positive and negatives. And it can be a really fun thing to explore as you're trying to come up with designs for these different processes. So I just wanted to put those out there because they're really cool. And I think it's totally worth looking at those just for a minute. And then there's some links here if you want to go a little bit deeper. And this one actually is worth pulling up. Yeah, like this guy who did, and this is all sort of vector art. And here's your vinyl record. There's just a ton of interesting ways to use this in art where you can imagine, and some of these are graphic, like this is using graphic things, but you can imagine this could easily be a sticker, right? If you were really a songbird or that was your, that was what you're going for. What a cool way to show that off with a neat interpretation.
Can you
so
put
there's
a
all
link
sorts
to
of
that in the chat where you are now?
Oh, is there stuff in the chat?
No, I was.
Yeah, could you put a link to that?
Could you put a link to that into the chat?
Totally. There you go. And then let's hop back to this. All right. So now those are really cool things to explore and awesome design features, but it's worth it, I think, to spend a little time and really drill down on the exact mechanisms by how these machines work. And so the first one that we're going to go after is the laser cutter, because lasers are fun. Everybody wants lasers. But with a laser, it's really an acronym, which a lot of people forget about. It's light amplification by stimulated emission radiation, which is a really fun and nerdy physics concept. Stimulated emission is when you get one photon to trigger the release of two other photons, of two photons. And so it's a really interesting process. I had a physics professor who said it's the only things humans have really invented is lasers, because it's the only thing that nature won't do on its own. I don't know if that's really true. It feels like we've done a lot of cool things, but it's an interesting point to entertain. But when you think about a laser, essentially what you've got is this beam of light that comes in, and it's infrared light. You're not able to see it, but it's a beam that comes in from a laser tube down at the bottom of the machine in the back so that you can't accidentally kick it. It comes in all together, and then the very last thing that happens to it after it bounces through a series of mirrors is it passes through a lens. And so it goes through a lens that's not unlike this blue thing here, although they're almost always colored yellow for us. And it goes through this lens and it passes through a focal point. where all of that sort of collimated light is brought into a single point. And so all the energy of those photons pass through one location. And with a powerful enough laser, which is not the kind that we have, you can actually pass so much energy through the air in a point where you can turn the air into a plasma, where you can put enough energy in that the air starts to burn. Our laser does not do that at all, but it will burn material if you have something at that focal point. And so I've got here this little green stripe, and you can think of that as like your piece of wood if you're cutting wood, or a piece of cardboard. And so at the focal point is where the burning is going to start. And then as you go down, hopefully it's not this wide. You want a 2-inch laser focal length is going to have that point be 2 inches away from the lens. And at that point is where most of the energy is going to be. And right around there, it's pretty compacted. But the longer the focal length, the more stretched out that is. And so the more vertical of a cut you're going to have. It also has some other interesting applications that this is how it works, is that you may, for particularly thick material, you might want to have the focal point be sort of on the top half when you do one pass, and then adjust the Z height so that the focal point is at the bottom half to do another pass, so that you can actively manage where the hot part of the flame is, or the hot part of the laser, so that it can vaporize away what's going on. And most of the time, laser cuts aren't actually perfectly perpendicular. They're usually tapered in a way, because this isn't quite as precise as you'd think, but it's hard to tell unless you've got acrylic, which does it really nicely. And so I would totally recommend you get to laser cut some acrylic if you want to take a chance. Here I've got a little bit that's in the room. It's going to be hard to see in the light in the camera, but 1/4 inch acrylic, you can really feel that it's not a perpendicular cut. And also below the laser, we typically have that honeycomb in the middle one, and then there's the black material on the right, both of which are metal. And that's really important, because once the light goes through the focal point, it starts to spread back out, and it never recombines into a point where it's focused enough to do any damage, which means that basically below the focal point, if you're far enough below, you're at no risk for fire or harm. And the reason why that honeycomb is metal is probably because it's easier enough to produce in aluminum that way, but also it dissipates away any heat. So even if it does get absorbed by the aluminum, it's able to spread the heat away really fast so that it doesn't actually do any damage to the aluminum honeycomb. So that's really important. But basically, this process will work for anything that you can vaporize. But what we have at MakeHaven as requirements is that it's got to be non-toxic as a vapor, and you shouldn't be able to dissipate energy faster than it's added. So it's why you can't put metal into the laser. You can etch the surface of aluminum if it's got an oxide layer, but really then you're just etching the oxide layer, not the aluminum itself. So those are important pieces to put in there. But no, you can't see the laser. It's invisible to you. It's probably the laser light itself is not something you're going to see. It can still damage your retinas, so you got to be a little careful. And the glowy part is actually the material vaporizing away, which is fascinating. It's not the laser that you're seeing. It's the glowing light. And so we're going to go a little out of order. But this is what you've got is your, let's see. Yeah, if you want to do a Zippo case in the laser, you can do that. You just need to make sure that there's nothing flammable in the Zippo, and you're going to be removing any sort of a layer that's on top of it. So you may need to put a coating on it. You may need to electroplate it somehow so that you can remove that plating, which is a little.
What's a Zippo?
Like the lighter?
It's a lighter.
Oh, of course.
Mm-hmm.
Yeah.
And so, oops. And so as you're doing that, as you're imagining the cut, like Kate was talking about when we were all getting here, a good way to save yourself a little bit of trouble later on is to mask your main materials. And so when you're using the laser and you're making a cut in a material, you may want to cover the top and the bottom with a masking. That feels a little excessive to me. I think when I'm worried about it, I cover the top and not so much the bottom. But some materials come pre-coated on top and bottom just to avoid this. But when you do your cut, the laser is coming down and it's vaporizing away the material. Anything that's really truly vaporized is removed as a gas. And so for the sake of wood, it's turned into a little bit of carbon dioxide and water vapor probably. But then the pieces that don't quite vaporize, they turn into a smoke that gets carried away. And that's really what the blowers are there to try and remove, so that you don't have, so that you don't have those things. Also, some of the coating materials, yeah, that's a good point. It's
Which ones don't make it worse?
Yeah. That's where you'd really need to look at.
I would say, in my experience, masking tape will usually, if you're getting too much charring and you don't want a charred look, you want a cleaner look, then you can use masking tape. Some of the acrylics come with it's like kind of a plasticky layer, some that is laser safe, but I found that it can do weird heat things and weird melting things. So sometimes I'll usually just remove it completely. If it's becoming a real problem, sometimes combine it with masking tape has been my experience, but Ruby may have more thoughts there too.
Okay.
Yeah.
Thanks.
I like to keep it on, the plastic on the acrylic. If it does melt, I usually just try to carefully sand it off.
Yeah, it's really like a case by case thing. I think that some of the adhesives are worse than others too on those maskings, where some of them turn into like a goop when they've been lasered, and others just sort of completely disappear magically like nothing was ever there. And so there's a lot of variety. I would say before you commit to a very large, time intensive or expensive cut, you do a little bit of test if you can. Is going to be the way to make sure that you get the best results that you can, and switch it out for another masking. The masking paper that's over by the laser is probably pretty good. Is probably one of the good examples of what you could laser away, would be my guess. But yeah, so the blowers mostly are there to keep all of your air moving out and to get rid of all of that smoke, but masking can totally help. The other thing that's important about this little image is that you've got a slight taper here, and you got to always remember that that's true. And we'll see that the same is true with the Waterjet, just as a thing to keep in mind. It usually doesn't matter, but from time to time, it's a thing that you'll have to deal with. Like if you're cutting acrylic and then you want to glue it, you'll need to sand that or file it flat. And then here's a good pitch for just like in general, how long do things take on the laser? It's always good to keep in mind the piece that I was feeling out this week to try and use experiences to make sense of is that a 4" by 4" thing takes about 15 minutes, 16 minutes. So if you're imagining that, you could say, just for the sake of argument, that like every square inch is about a minute. So that could be useful just for estimating sort of where time will go. It does play with the settings, but one of the things I've noticed is that it tends to not, if you speed up the laser, some people try and make the laser go faster so that it actually happens faster. And that was a problem when I had a teacher who also worked at the school that I was at before. They would try and run their raster prints faster to make the whole thing go faster because they had 20 kids to laser in an hour. But the issue is that it's most of the time is eaten by the laser turning around when it gets to the end of its raster run. And so speeding up the laser doesn't actually help it that much, because then it needs to slow down more, stop, and turn around to go back the other way. It seems like it doesn't help or change the speed much at all. But those are all interesting things to take in mind as you're imagining what your cut's going to turn into. Let's see. And
if changing the speed of the laser, wouldn't that also like sort of linearly affect the amount of energy that's actually getting put into the material at a given point?
It totally does. And so in that case, the teacher notched up the speed and notched up the power to sort of match. Okay. They were hoping to try and get the same amount of burning in less amount of time. Okay. And it just doesn't work out that way. I think, you know, like it was 10% faster and they had tripled the speed. So yeah, it's not like it's a major lifesaver. But one thing that's really interesting for the laser is that even though it's just cutting with light, which you don't think about as taking away much material, there's totally a kerf to a laser cut. And that makes sense if you cut a single stripe, there's a piece removed and you can see that it's been removed. But sometimes it's hard to, like, you forget that piece as you're imagining what to do with your designs. And so here, actually, in the past, I've gone through and I had a lot of, when I was planning for students what they would build, we'd build a lot out of cardboard because it was cheap It was quick to cut. It was, you know, worked pretty well. But I bought 1,000 sheets of cardboard, all identical cardboard. And so I wanted to know exactly how wide should the slot be in order to get a really nice fitting notch where things can fit together, sort of like these hexagons down here. And it turns out that when you make a cut, you lose material on each side. So it was smaller. I had to change the size of the cut from the actual thickness. If you measured the thickness of the cardboard with the caliper, I had to move the side walls of the opening in a little bit because the kerf would widen it back out. And so those are all pieces that you'll need to plan for if you're trying to get exactly perfect fits. Like if you want to do pre-cut joinery is totally a thing. And I'm going to drop a video link in the chat. I meant to do this afternoon. I'd emailed myself, but I'll send a link to a video that goes over this for finger joints. So if you want to do real woodworking joinery, you can totally do that with a by thinking about how much the kerf is a factor in your game, and then adjusting. If you don't do that, it'll still fit together. The kerf isn't huge on a laser, but it is enough that you wouldn't have perfect fitting tabs. And so if you really want a nice, completely solid connection where it's a friction fit and the two pieces won't fall apart, you have to take that kerf into account. And so those are interesting things. Another fun part about the laser kerf is that you can use it as a way to bend things. And so you can make interesting bends in wood where it becomes completely floppy in a way that you would not expect. It's totally worth doing at least once just to see how much bend you get it in. And so, yeah, there's a ton. This is the container on the bottom is actually something that you can get made completely programmatically. And so we're going to look at that in just a second. But these are examples of things that have totally been made by getting just a friction fit between the materials, except for this one, which we'll go into a little bit more. So if you're one of the big pieces about the laser that really makes it probably one of my favorite machines in the lab is that you can do this 2.5D construction where the laser is one of the fastest ways to make something, right? You're doing a series of small cuts and you can use that to build things together. 2.5D construction's useful beyond the laser, and we're going to see that it works on a CNC also. But it's totally something that you can do and you can explore with the laser pretty nicely. And so, like up over here in the top right, this is a piece for my robot bartender where I have all these holes for mounts for motors to be in there. And then I've got this edge wall. And you can see all those laser cuts in there. That's so that I could bend the wood nicely around those big curves and be able to get a nice even curve from solid plywood. And so when you have those cuts, you're able to make kerf bends, which is really neat. But you can do all sorts of three-dimensional construction. Like here's some cardboard that's 3D constructed, or the dust shoe is 3D constructed. But makercase.com is a really fun place. And there's like 3 or 4 of these services that are out there where you can say you want to make a polygon box, right? I can come into here. Let's zoom in a little bit. I could say I like hexagons. So let's do 6 sides. I want that to be my outside diameter to be, I don't know, 4.5 inches, outside height to be 2 inches. And the material thickness, we'll just stick to 1/8. And I'll have an open box with finger joints. So like you can have this programmatically designed for you. And this is one of the services that exists like this. There's like 3 or 4, and I'll do some legwork and find a few more of them. Like there's a Python one, Python laser cut designs. There's a bunch. There's laser cutting projects, even on Thingiverse, where you can get to a whole bunch of laser cut projects. So if you haven't seen this yet, this is totally worth it. These are not so much designed as they're not programmatically designed. Usually these are labor intensive things that people have made, like a tissue box cover or like a little shadow box to look at. There's tons of interesting things on Thingiverse that you can explore that are also good laser cut examples. And so there's tons of fun things to look at that can really get to the core of some of these deeper skills. Like, look at how crazy that is. That's pretty neat. But with that, there's that, and then there's programmatically making just simple boxes, which can be really helpful. We're going to also explore this just a little bit deeper. So if you're trying to build things with 2.5D construction on the laser, this is a good way to go about building things. So if you're trying to build stuff in a way that it can be made and unmade, finger joints are great, but usually you have to glue those together, or temporarily you can have them taped. But when you want to have a semi-permanent connection, I really like this trap nut joinery that's shown down here in the bottom left. And so it's a sort of bizarre joinery style that a woodworker may not like this as like a pure woodworking task, but I find it to be really handy if I'm trying to build things then I know I will also want to unbuild. And so it's this pattern where you have a hole that a bolt can go through in one material, and then the bolt would go down through this slot where you can have a nut that's added in there. Now the nut fits in, and you can see it fits in here, but it just barely fits. So that when you put the bolt in and you sort of thread it into the nut through that slot, it doesn't have enough play on the nut so that it's trapped and it can't spin. This piece on the right is working like a wrench on the nut, keeping it from spinning and making it so you can screw the two pieces together. Or I think the most helpful part is to unscrew them so that they can be unattached. Was there somebody trying to ask a question in there? And I was just talking. No, I just want to give.
I'd like to see more examples of this, because this is definitely something I'm interested in.
It's totally a cool. I'll pull some up for when we do show and tell. This is another one that's a good example. This was a piece of furniture that's maybe, I think it's 24 inches tall. And so in here, there's a few bolts to hold that together. And I've got a few more pictures of other projects. I just didn't queue them up quite as much. We'll circle back to this, but it's a really fun joinery style for putting things together. And so there's tons of interesting opportunities for that if you're trying to build stuff that you can unbuild. But kerf bending is worthy of its own whole slide. And so I would really like it to see sort of what people do with kerf bending this week. There's tons of opportunity with it. It's super, if you haven't ever held a piece that's got a kerf cut in it yet, where you can do a bend out of a piece of wood, it's almost magical to take a rigid piece of plywood, stick it in the laser, do some cutting, and then you pull it out and the whole thing's floppy, right? It's a little hard to wrap your head around how weird and wonderful that is until you really get it to happen. And so there's a ton of good examples. I've got like a list of videos that I'm going to send out through Slack and then probably post in some other places where I've seen people make purses out of this, where the purse hinge is there. I think the screensaver at MakeHaven on the laser is a book binding, sort of like this journal down here in the bottom left. There's tons and tons of options for this. There's lots of interesting ways that you can use it. In traditional woodworking, usually it's a partial cut. It's not all the way through because it's hard to stop where you're cutting and then restart cutting again. On the laser, stopping and starting where you cut is super easy with a vector. And so instead of being partially cut through the material, vector cutting for kerf bending is usually done where it cuts all the way through, but in just a little segment. And so you can start to have repeating patterns that make it more and more flexible. And depending on the pattern, you get different kinds of bends. And the density will also impact how much it's bendy. But a key part of the design, and I've made this mistake before, is that you need to make sure that it's a continuous piece of material still. You can't like accidentally cut it in half with your kerf design. So you got to be careful with that, which sounds like it should be obvious, but then you go to design one and every so often it catches you off guard. But it's not super hard to design this. You can just do it with a series of striped lines. And so it's a really fun thing to do. I love this little, like, I don't know, the Greek swirl down here and this one that makes it very floppy, this particular piece. But it can be used for all sorts of things.
Is this, hey Corey, is this better with cardboard than wood?
I think probably with wood, it's really striking because the wood is rigid before. Cardboard, you can always sort of bend just by hand. And the wood goes from completely rigid to totally not. But if you do the right design, it can be not rigid in one dimension. Like in this example, I wanted it to be not rigid around here so that I could bend the wood, but I wanted it actually to be completely rigid vertically. And so because I only have vertical stripes, and there's like, you can imagine a little column of wood at each point, I have the full strength for the height of that, but I've really weakened it along the dimension where I want to make my curve. And so it's a fun process, and I've done it easily the most with wood, but you can do it with cardboard. MDF doesn't do it very well because MDF is kind of a weaker material that will, I would say it's brittle. It will snap instead of bend nicely unless you have a lot of kerf cuts in it. And so that's something to take into account. This is probably going to go best for you if you have a small sheet of plywood. And I know that they have those in the store in the back for about $5. So if you wanted to get one of those or just use a scrap piece, it's totally something that's worth it to make a 2-inch strip just to see how weird it is at the end of the day. But yeah, and then keeping an eye on time, we got to keep moving forward. So the vinyl cutter. The vinyl cutter we talked about a little bit last week, but we haven't gone into much. And it's one of the things I want to do this week. I want to go in and use the vinyl cutter and try and get some of these pieces worked out to make sure that it all works well. And just to have some more experience. This is a great way to make decorations for your own things. But the key is that a vinyl cutter is more than just what it says it is. It's really a plotter, like used to be used to draw architectural drawings. But instead of a pen, it's got a knife. And in some vinyl cutters, you can swap that knife back out for a pen and then use it to go back about the business of drawing, which is really a cool way to go. If you want to make a very large, very specific pen drawing, you can do that with a vinyl cutter where it draws out exactly what you want and it can be very precise and scientific. Sort of like JR's drawing bot up on the wall behind those couches. You can make the vinyl cutter do the same sort of thing if you just swap out the knives for a pen. And usually I've seen this done with like a 3D printed adapter that works for your particular thing. I've tried it with a pencil, but what's hard about a pencil is that the pencil gets shorter as it writes. So it works really well for the first, like, I don't know, 15 inches. And then after a while, it gets less and less impressive. But using a ballpoint pen, the ballpoint will keep rolling and rolling and rolling. And as long as there's ink in the pen, it'll keep drawing. So I would love to see it if somebody had a really slick pen drawn thing on our vinyl cutter. Unfortunately, I don't have any good pictures of one of these, but it's just you'll know it when you see it. It's a crisp, beautiful pen drawing. Another thing that's really impressive about the vinyl cutter at MakeHaven is that it can use registration marks. And I don't have any pictures of this because it's one of the things that I want to try and figure out this week. And it sounds like Kate might also want to. So maybe we team up on that. But the key is that the MakeHaven vinyl cutter can also identify registration marks, and then you can use it to do some interesting cuts. But we'll get to that in a second. One key piece of the vinyl cutter, if you've made some stickers, is that in order to move them around effectively, to make these like beautiful wall stickers of the world, or this, I'm going to go with Indian lady dancing. For those, if you buy them, they usually come with a masking that's over the top. And so to pick up and place stickers, you'll often have to think about how are you going to mask it and how are you going to pick up the vinyl and put it on where you want to go. If you've ever bought a sticker like for a laptop, they always come with 3 layers: the backing that's on the sticky side of the vinyl in the middle, which is the one that you keep at the end of the day, and then the masking that goes on top. And so thinking about the dynamic for those 3 layers is going to be important pretty much every time you lay a sticker, with a few exceptions. If you have one continuous piece as a sticker, you may not have to do a masking if you don't want to, but the vinyl comes on a backing. So you're going to be thinking about the dynamic between the vinyl and the backing when you make your vinyl cut, because you want to cut through the vinyl, but not the backing, which is called a kiss cut. And hopefully that's how it works. If the backing gets cut up, it's usually fine, but it can also be really annoying when you're trying to place it. And then masking can be really helpful. Over here, you've got a former student of mine who put a masking over a sticker. And this is on this side, it's her laying down the white lettering on the black background. But then later she used that masking as the way to pick up the sticker as a whole and be able to place it on a window. so that you could have it placed nicely and still sort of be able to move it around without having to touch the sticky part of the vinyl. And so those are all interesting pieces. And as you think about your particular sticker, you'll want to have to imagine, do you need the masking to get things transferred? And so as you're doing that, and as you're thinking about transferring stickers around, there's lots of interesting things that you can do. One of them that's really cool on the vinyl cutter is adhesive vinyl lettering. And I love the Little League photo here, but for this, iron-on lettering is a really great way to use the vinyl cutter. You can make any shirt design. It can be, you know, like sports names. It can be the shirt that Kate made early on in the class for the wearables week. There's a ton of options for iron-on logos and things. But one of the key pieces that you have to remember is that you have to cut the reverse of what you want. And it's totally something that I've done where I've cut the design exactly how I wanted it to look and forgot to reverse it, which is like frustrating when you do it one time. But yeah, for Kate likes to do the masking every single time. I think that the masking is actually pretty much always a good plan. But when you're doing vinyl lettering, the masking is on the back. So you're cutting it sticky side up. The stickiness of the iron-on lettering is only activated by the heat of the iron, and the masking is the backing at the start. So it linked in my brain that these are sort of backwards pieces, but because of that flip, because of that inversion for the vinyl lettering, you've got to make sure that you plan to flip it over. And so you do it once, it's like an accident. But if you were cutting the names for every kid on your Little League team, only later to realize that you'd done it backwards, that's a pretty expensive mistake. So it's totally something that you have to keep in mind. Oh, and for layering rubber stamps, that's a good point. There's a bunch of good examples. So anytime where you're going to do this, mirroring your image is something you'll have to think about if you're going to use it to be transferred on, and the adhesive or the imprint is going to come from you flipping it over and using it, which is sort of an odd thing to think about. It's something they rarely have to imagine with professional players. Those are stitched on fabric letters, but it's the same thing. And so those are all interesting weirdnesses that you have to take into account. But one that I think is a little bit better that can really push a design forward besides those details is how do you do multicolor things, or how do you use a registration mark is a really helpful tool when you're using the vinyl cutter. Those other pieces I feel like are details that you need to keep in mind as you're going, but registration marks really changed how I used the vinyl cutter. And so here I've got a picture of Buttercup, which is, I think her name is Buttercup, one of the Powerpuff Girls. I don't know. It's been a while. But she's a lovely little cartoon character with a very simple palette. And so she makes for a good sticker because you can ultimately boil her down into 4 colors. You can have a black sticker, a green sticker, a skin tone sticker, and a white sticker. And those 4 stickers layered together could make exactly Buttercup. And so, yeah, there we go. The key here is that for her, getting those to be perfectly aligned when you lay them down would be really, really hard. But if you put rectangles like this above her, and I put them in blue just for highlighted effect here, those marks would be cut with every one of your colors. So you have the same color, all 4 colors, they all have those registration marks up at the top. Doesn't actually matter too much about what their geometry is, just so that they're there and in the exact same place. And so what's really cool about this is that if you have this and you've got the masking all lined up right, you can get it so that you mask over it and your masking covers the rectangles at the top, including the black sticker here. And then what I have done in the past is I'll start to peel up that sticker from, and maybe not for the black one because that was the first one to go down. But then if I want to lay the skin tone one, let's say next, I'd put the masking down over it. So I've got backing and then the vinyl and then the masking over top of that. The next thing I would do is start to peel up the sticker, registration marks first. And then when the registration marks are free from the backing, but the rest of the sticker is still on the backing, I actually cut the backing there. So I can just stick down the registration marks and the rest of the sticker isn't sticky yet. So I can like very carefully dial in the registration marks so that they're lined up exactly on top of each other. By the end, you're going to have a sandwich with all of those different colors of registration marks, but it's fine. You just pull them off at the end and no one will ever know that they were there. They end up like a pile. I don't think you do it in Connecticut, but we get stickers every year for our registration on a car's license plate. So by the time you get a new license plate, you're like 8 stickers deep. And that's sort of what this would be. You'd have a whole bunch of little rectangular stickers that you remove. They don't need to be rectangular. They can be any shape. But I find that a corner is more helpful than having circles because you get something to register for your angle. Is a little bit easier with a corner there. But these are the sort of traditional registration marks that I have used. The new to me ones are the kind that would be printed in place by the large format printer. And then the vinyl cutter that's specifically at MakeHaven. Oh no, letters would totally work. Kate says she just uses letters. I think if you throw a K or an R or something with some detail in it, I think that would really help for a registration mark. It's super helpful. But then there's also printed registration marks. And I'm amazed that the vinyl cutter at MakeHaven can observe printed detail on the vinyl. But it can, if you print registration marks in the software for the vinyl cutter, you can get it to register and recognize those registration marks. And then it will sort of know where the printed pieces are on the vinyl that you're working on. So you can imagine designing in the vinyl cutter software, putting in the registration marks that you need, taking that back over to the large format printer, printing it there so that you have the thing that you want plus registration marks added onto it, and then taking that printout with vinyl back to the vinyl cutter. And then it has a little camera to observe where the registration marks are so it can cut exactly around the text you want. So in a sticker like this, you've got your text and then it's cut out relative to the text, right? Or in this case, it's maybe printed even beyond the sticker border and then it cuts out the border that it wants. So there you have the printed content taken in tandem with the cut itself, which is really a way to get a nice professional looking thing. There are some machines that'll do this all in one shot, but they are wicked expensive. I've seen them, they're magical, but it's like we have everything that we need to do this here. So it's totally worth doing. And I want to try and make it happen this week just to see what that looks like. Let's see. And yeah, it's a neat trick. Let's see. For registration marks on this, yeah, this is a really good, you just lay these marks over top of each other. And so maybe I'll go through and maybe I'll make a Buttercup sticker for myself, throw it on a laptop, just to show what this looks like, because it's really an interesting procedure once you see it laid out, that those just layer on top of each other and that's it. This is exactly the design file I would put. Actually, I have this file. I'll just post it to Slack. And if anybody wants a Buttercup sticker, you can totally have one. So yeah, you just take and make the 4 stickers and you put them together and that's the whole bit. All right. And so then the last one that I want to take a look at a little bit more in depth is the Waterjet. And so the Waterjet is a really fascinating machine. I don't know if any of you got to it this past week, but I really hope that someone does. I know that Lila was looking at it and I hope that, yeah, that was Homer from last week was used with registration dots. It was a really good piece for an example of that. The Waterjet is something that is, I would say it feels like a more complicated and intimidating machine, but it's actually the exact same process. The real amazing thing is that it's all essentially high pressure water and sand that does the cutting. There's nothing secret or magical about it. It's just high pressure water. And because it's water, which is a coolant, basically it's cold cutting. So there's no heat involved. And that means that you can essentially cut almost anything and it works really well. The hard part is that like these pieces in here, they're all super hardened to deal with all of this cutting material moving through without themselves getting cut up. And when you have something that's that hard, it's also very brittle. And so this end to the Waterjet is something that can break from time to time, and it costs about $200 to replace. So you got to be careful with that. It's worth it to be cautious, do it with a facilitator around, but you totally can make some really cool stuff. One of the neat things, and one that I haven't seen happen very much, I think the facilitators in particular who run the Waterjet the most, they're super into metal work. And so they just cut a lot of metal, but it can also cut all sorts of other things. Like here's a piece of granite, or I don't even know what this orange stuff is, but you can cut through glass, you can cut through mirrors, you can cut through apples. I love this subway tile thing cut on a water jet, where I can imagine just like being in the subway and like, boom, there's a little tiny piece of art that you wouldn't have noticed. I love that. Or you can do completely ornate marble floors where you water jet cut the wood to, or not the wood, the stone into the exact shapes that you want. And because you can plan for the kerf exactly where you want it, or you fill it in with grout, you can have a really nice piece that's got as much detail as you want to go through. And so in some fancy palace sort of a place, you might have a very ornate detailed piece, or, you know, on a really fun bathroom floor in a house that you own. That could be a lot of fun. There's tons of interesting things to look at. But because the cutting action is actually not super dissimilar from the laser, it's a downward cut. There's not a lot of torque motion on either side, but it's sort of a downward motion through. You have the same exact problem with the cut side. So this is a metal piece that's cut out here in the middle. And if you don't get the settings exactly dialed in, you can get a taper on these cuts so that they're tapered down a little bit, or so that they're tapered out a little bit. And so those are all important settings to dial in. You can't just assume that the water jet's going to give you fully precise, like machinist level precise settings, because you've got a lot of factors that you have to dial in. And the software, the OMAX software, really helps with that. But it's also a little bit tricky to make sure that you get it exactly right. One thing that we're going to see come up again as a later recurring piece is the idea of tabs. We talked about islands at the very beginning, and now here we are kind of at the end of our time slot. And islands are an important piece to keep in mind whenever you're doing your design work. And if you have an island on the laser cutter, an island is not a big deal. It just falls through the honeycomb and it lays there on the bottom until somebody cleans it, which isn't really a huge problem. But the water jet, if you have an island and the island falls through, then you've got a bigger problem. On the vinyl cutter, they just stay there. Like, you have to weed them out later. It's not a big deal. But on the water jet, if you have a piece that falls through into that water bath below, now it's in that stagnant water and you're going to have to go fishing for it, which isn't really ideal for a whole bunch of reasons, including there's sharp things down there. And it's probably bacteria laden just because it's water that sits still. So you add in tabs as a solution to that problem. This design, if it was being cut out of sheet metal, would have this piece in the center that if it was able to cut just like this, it would completely just fall out. It would not be attached. It would fall through, and then it could be lost down to the bottom. And if this is a piece that I don't want, then it's a piece of metal sitting at the bottom of the water jet rusting slowly. But this piece right around it, it would be an island in the piece of sheet metal, and it would fall in, and then the piece I want is down there, which is pretty bad. So you add in tabs. And so tabs just take your cut and they interrupt them. In the OMAX editor, it's actually super easy. You just hit Control T and it'll start to plop in tabs for you. But the pink line here is where it does the cutting. And then a brown line is where it ramps down or ramps up. And then a green cut, or a green line, is a no cut traverse. So it's coming along here, and you tell it you want it to put right there, and it will stop cutting, come out here a little bit, and then start cutting back in. So it finishes the shape, but you've got this little slot that isn't cut. And in this case, I put in 3 and I circled them so they're nice and clear. But those 3 would be enough that it holds it in place and it doesn't fall through, and it doesn't deflect downward. So those would keep me from having real islands because they're connected by a little tiny bridge. And in metal, that little tiny bridge is probably going to be enough. We'll see when we get to CNCing things that you'll probably need more substantial tabs, and that they get made a little bit differently. But this idea of islands and tabs is something that we're definitely going to see multiple times as we move forward in the class. So those are all important things that you have to keep in mind as you're doing sort of more advanced designs. Now, the goal for this week is not necessarily to make more advanced designs. It's just to try and push yourself to try all of the machines, to try and deepen it a little bit further. There's lots of ways that you can get more complicated with these machines. And some of you are going to do that in an artistic way, and some of you are going to do it in an engineering sort of way. Not that those are opposite or opposed. They're just sort of different goals to go after right away. Hopefully they get to converge. That's always the funnest. But a good way to bring a more complicated idea from a design standpoint, from a structural design sort of standpoint, into software for these processes is through Dxfs. And so DXFs are digital exchange files, although that's sort of a loosely translated thing. A DXF will let you go from a 3D design into any 2D format you want. And so for the dust shoe, I totally made these designs and then pulled out DXFs of those shapes. So in Fusion 360, which is the software I use, you can click on a shape, make a sketch, and then export that sketch as a DXF. A DXF is probably going to be hard to edit inside of Inkscape, but basically you can just load it and then it's going to give you exactly what you want. So here on the bottom left, I've got a few DXFs that are just loaded in a page that's a 12 by 12 sheet of acrylic. And so I can get the design that I have from 3D design software to be precisely cut by importing those vectors, taking them out of 3D design software and putting them directly into the vector software that I use for cutting. So it's a nice way to exchange information back and forth between softwares.
And
It's
is that what I used on Illustrator? You
Yeah.
sent me that. Okay.
Yeah, DXFs are
Yeah, that was totally helpful.
It's what I sent, and they're usually not very editable once you get them into one of these vector softwares. Like you can add things to them, but usually you can't break them up very well.
Yeah, I should just tell them that I was not able to edit it, but that didn't matter. I just needed it in order to place the robot correctly. So
Yeah.
it was my canvas.
Yep. Yeah, basically they can be really great for that. It's one of the nicest uses for them. And DXFs can be interesting in that they can be these cuts for like, this is a flat panel on the side, but then this piece right here has actually got a curve in it. And so if you're doing 3D design work, which eventually we're going to get to in a couple of weeks, but that piece has got its DXF right here. And you can see there's these red lines in it. Those are bend lines. And this is a piece of sheet metal. So even though it's not really sheet metal, I use the sheet metal design tool where I could design in bends into what I've got. So you can factor in lots of different things. There's tons of interesting ways to use that. And if you're already like a 3D design pro, I can imagine someone who's really good at designing for sheet metal bending and then outputting DXFs to the Waterjet so that they can exactly cut what they want on the Waterjet to bend it up into a metal box or to a metal housing for an electronics project. It could be really cool. There's tons of interesting options for how to do that, but DXFs are a great exchange format to go back and forth between the two things. And so it's a great opportunity to try and expand the way that you build designs. But there's tons of interesting designs that you all have done over the course of the week. And I'm really excited to see sort of what got made. And so let's see, we're pretty much at time. Does anyone have any questions? I feel like there was the least talking we've had in a while during this.
I had some questions about just finding those register points, and if you have videos to demonstrate that. I mean, I get the overall concept and why you'd want to do it. Hello? Oh
Yeah.
I thought my computer just lost Zoom. I
Nope.
see what you're doing.
You're good.
Okay.
Cricut actually has become super popular. This is like, I don't know how much these cost, less than $200 to buy, maybe about $200 to buy like a Joanne Fabrics. And so they use registration marks all the time. I don't love one of these, like you have to pre-purchase every design, which is kind of mind blowing. But some of them you can do your own design work, these like lower end vinyl cutters, but they use registration marks like this to line things up. And so there's tons and tons of videos that have proliferated as Cricut has started to exist. And so let's see, there's a bunch of good examples. Here's someone doing the Taco Bell logo and they're like running through the design work. Which is like, it's actually a good example, right? There's only a few colors in the Taco Bell logo. And so they break it up into its different colors. They add in registration marks and then let's see. Oh, they don't have any like physically putting it together. Let's see. That's why I think I'm going to make the Buttercup sticker just to show you what it looks like. They use a star for the registration mark, but you basically want to line it up so that the stars would land right on top of each other. And if those are right, then everything else in the sticker would be right. I like to use two sort of spaced apart, which is why I did that for Buttercup. That way I have like, when I'm laying these down, I try and make sure that, let's say I do the green one second. I put this top corner right over the top corner of that. And I put this top corner right over the top corner of that. Make sure that it's
Oh,
lined up
okay.
that way.
I see it now. Okay.
And then once those are good, and like I've checked
Mhm.
all 8 corners, the rest of it usually comes out just fine.
Cool. All right. That makes total sense.
It's super helpful. And the example one, Kate was totally right. Let's see if I can pull up in here. Let's go back to our little chat. We're looking at last week. There's in here, the slides. The slides from last week had that little Homer, had Homer in it. And it's actually really good as an example, just to see sort of what exactly this can turn into. Oh, that's the same exact ones that we're looking at. Whoops, sorry guys. Let me stop sharing and find this. I want to pull that up just to show you what's going on. But the registration marks are tricky. Like, it's a subtle thing, but it feels like a superpower once you get it. Let's see. I just don't have a good photo of it. But this week, hopefully we can get that to work. All right, share this. And so, like, to get all of this Homer stuff to line up, it would take a lot of work to be you'd have to be really good at just doing this freehand. And I'm never going to be good at doing that freehand. So this student put in a rectangle up here and a rectangle up there, and they could line it up based on those rectangles to get the rest of this all aligned. It means that you might waste a little bit of vinyl, but if you're committed to the design, it may not, it's probably not a lot of vinyl that you're going to end up wasting. Or if you think about where do you want to put it, maybe if you put them on this side, you'd waste less vinyl, right? It's a little tricky thinking about exactly where and how you want to put them. But basically, once they're placed, you're fine. You just want to stick to the same side. If you cut them on opposite, if I put one up here and one down there, technically they might be better aligned, but then I have a harder time getting those to be sort of attached and then being able to play with the backing underneath it. So it's definitely sort of an art, but once you see it happen once or twice, it makes sense. And so I'll try and document doing this process this week so that we can see how this works. I'm going to try and spend a fair amount of time at MakeHaven over the course of the week, just because it is my winter break and I want to be there to sort of button up all of the details of this week, get everybody caught up, make sure everybody feels good about electronics, because I think that's where we're going to be headed next. I've done some ordering for electronics pieces. We're going to have an LED week, a whole week dedicated just to LEDs, which is very exciting and blinky and fun, because there's some subtlety to those. And so I did some ordering for that, and then we're going to spin that up into how do you design circuit boards if you wanted to, or how do you design circuits, a little bit more about circuit schematics and some of those pieces, and making sense of the other players in the Arduino space. Like, what's a Raspberry Pi and how does that work? How does a microbit fit into this, and all those sorts of things. So I think that after this week, we're going to head there just to sort of ping pong back and forth between design minded things and electronics kind of technical things. Some people do really well in each of those camps, but usually the people who are really good in one of those need a break. Or, if you're not good at one of them, you want a break after 2 weeks. And so I feel like it's good and healthy to keep that rhythm going. So
Corey, after this week, if we look at like the unit list, what are we moving to?
That's
Is there a number or whatever?
10. So we're in 7, and because we did 8 already, and then 9 is another design one, I want to skip it and go to 10. So we're going to go to unit 10, which is LED week, and then we'll circle back for 3D design afterwards. And then after 3D design, it's back to another technical one. So it keeps us in the sort of ping-ponging technical design minded world.
So next week is LED.
Next week is LED. Yes.
Okay. Cool.
Next class is LED. This week is continuing.
Correct. This week is continuing, and hopefully we get to see some really cool things that have been made with the vinyl or laser cutter. It's show and tell time. And so I want to see what everybody made. I want to help you make it even cooler this week, and then sort of see what's going on. So would anyone like to take the lead in sharing what you did?
Well, first I want to say I think Homer Simpson's very inspiring to do that layup. So
Yeah.
yeah. Yeah, so I can start. I created a Christmas tree cut out of what was that, Inkscape. This is how it turned out. I couldn't see my family this year, so I'll just be sitting on a bunch of ornaments. I made a bunch of them. So things I've learned from this is make sure that the wood piece, as you're cutting it, is aligned, because some of it came out a bit shorter. If you notice these, they're yeah, so it wasn't too bad. But yeah, so I had a little bit different coloring, shading for some of the patterns on here. I had about 30% power for these balls. I had about 50%, I think it was, across here, and then 75% to cut out the trace along here. So we were talking earlier that there was an issue in kind of penetrating the piece. So I pretty much just laid up the trees, one this side, one the inverse side, the traces across the board, but it didn't quite make it through this one on the end. And so I think it was because the board was a little bit warped or something, because I had to go through 2 passes, but yeah, it didn't quite cut through. So
Were you using the universal or the epilogue?
I think it was universal. Is that right?
The
Yep.
middle and the right one are universals. The epilogue's all the way on the left.
Yeah. So I was using.
was.
Yeah. So I'll
Did
use
you-
universal on this.
Did you find that the table of suggested settings worked for you, or did you have to fiddle around to get the effect you wanted?
I found that it worked for the first cut just fine, but because I was laying them up in like this configuration, one after another,
Mhm.
it was a little bit different for each of the cuts, you know.
Right.
So I think like alignment and maybe getting some more weight to hold the piece down next time.
Yeah,
Yeah.
I'm remembering your piece. Your piece was warped. We even like stuck we cut the first tree like in the top corner
Mhm.
and sort of jammed it so that it was down flat. And I'm wondering if they were cut like along that piece as it wandered up, right? Your hot part of the focal length is staying in the same location,
Yeah.
wise, but your wood is sort of creeping up while the cut point is staying low. So maybe it was that like you weren't quite in the hottest part of the laser.
Yeah, maybe. So, yeah. So, but I'm pretty satisfied with it for the most part. You know, so I'll just have to put a little force to get that little hole out. You know.
Yeah,
Just,
I've sanded sometimes on the back for a piece like that, where if you're close, like if it's almost there, especially if you can hold it up and like see the light through it, sometimes you sand the back a little bit and it'll remove enough material that it just pops out.
Okay.
But
yeah, because I mean, it looks like it made it through most of it, you know. So I think just a little sanding, I think would just take that out pretty good.
Yeah, sand the backside. You'll never, you won't even really see it.
Yeah. Yeah. So that was it. I guess I could show you. I wasn't able to come in last week, but I could show the electronics project. But I'll wait till everybody else is finished for
Sure.
the sake of time. So.
All right. Jamie, you're unmuted. You want to go?
Sure. Well, I left the samples I was working on for the raster. Well, actually, we went to Vector for some of those Illustrator files I showed you folks. I turned some photos into vectors and had some success. You know, dialing in the right settings to get really nice crisp lines. It took a little while, but the repetitiveness actually helped me get really comfortable with the machine. And so did the machine finally just shutting down and, you know, not being nice to me either, Ruby. So, right. But I learned how to, you know, get rid of, you know, cleanse the memory, troubleshoot. So, and then I also made a box. What I wanted to do was to make a box and then have some of my illustrations on the box. So I'm going to try that again this week. And I played around with making a curved box. And we started off with cardboard, and Corey showed me how to do that. And that's what I did. And
Maker Case
it was a lot
is
of fun.
great. Yeah.
Yeah.
It's such a neat process. And I feel like the struggle with when I do engineering laser cuts is usually what I'm doing. Like, I guess not engineering, but like cutting shapes to build stuff. I rarely build decorative things on the laser, but it's a totally good use of the laser. And dialing in those settings to be perfect for your particular application takes a while. I feel like that's what you nailed.
Yeah, you know, this weekend, this might be a little ambitious. I was seeing some like three-dimensional models put together, but like in layers. And I also saw that it looked like an atom.
Yeah.
It's hanging up, and those are really cool. So I was thinking of ways to combine that with LED week. If I can get some of that technique down this week, it'd be really cool to make shapes and implement lights into them and make really cool lamps. So
Yeah.
if anyone wants to work on that project with me, it would be really fun. So
I'm dropping in the chat right now. So I found there's some really fun things to try. Here in the chat is and let me just pull up. I'm going to share my screen really fast. A good, I guess, because LED week is coming up next. Let's see, is my screen, it's not shared yet. Okay. Here's an example of something that would be fun to laser cut.
Yeah.
Where you put LEDs at the bottom and then you illuminate from the edge all of the things, and all of the etchings in it light up extra. It's just a total internal reflection game where when it's not glowing, this is what it looks like. But then when you have the light turned on, this is what you get. And so pretty much any logo that you want will do that. And it's going to be brighter on the bottom and dimmer on the top. Like, those are all things you can plan for. But it's a really cool way to get a glowing effect that can really illuminate and look nice and classy. There's definitely professional displays that use this exact technique. So there's tons of cool things to do with that.
Yeah, that's exactly what I had in mind. But
yeah.
I would like to do something layered as well, but that's pretty cool.
Mm-hmm.
White, is that etched or is that like ink?
It's etched. Yeah. Yeah, which is cool.
It doesn't have anything up, like, I know there's some products that you can apply into acrylic or whatever to make it pop, or is that just a straight etch?
It should just be I've done it before with just a straight etch. There might be things that make it better, but just a straight etch works well.
You did that, the Gryffindor one?
I didn't make that one, but I have made them. I have, my stepdad really likes cars, and so I made him a Ford Mustang one. You know, I've done that.
So how would you like use acrylic within this? You cut it out, and then has anyone done that here?
I haven't done it here, but it'd be fun to do. You just take acrylic. So like here's a piece of acrylic. Now they're coasters on my table, but the acrylic here, you just do like you cut out your shape for the outside, make it flat on the bottom so you can sit it on top of some LEDs, and then you etch into the front the design that you want. You don't have to etch it on both sides. It's just the front is usually enough. And then the light coming up from the bottom, when it hits the etches from the side, it'll come emitted out the front of it.
Oh. Okay.
It's a really fun trick.
Yeah.
All right. Who wants to share next?
I can go.
Yeah.
So in terms of the like strictly vector stuff, what I did was I made a little leather patch that I then attached to a sketchbook for my brother. And I took a painting that he had done of his cats. And I like simplified it and turned it into like just a two-tone image. So it's a little abstracted, but I don't.
Yeah. Oh, that's so cool. And is that on leather?
Yeah, it's on leather. This was one that was like at slightly lower power settings. The actual final one is on the sketchbook. I don't have it in front of me.
Yeah.
I had a very strange problem with the laser where it was just stretching the design. So it was more or less a square, but it was making it very, very tall. And this was about 10 or 11 p.m. on the 24th. So like at some point I would like to figure out what the actual problem was, but I didn't really have the time or the like mental presence and focus to you know, like figure out what the base of the problem was. So I just like it was printing like this.
Oh, yeah.
So I basically just compressed it in one direction by, I think I made it about 55% of its original height, and then it stretched it so it was right. It's not the most elegant solution, but at that time of night it worked.
Yeah.
And then I think it's kind of vector oriented, but it was with the CNC, not the laser. I did the other kind of kerf bending that Corey was talking about with a drawer for the nightstand I'm working on. So like here, these are like all of the kerfs that I cut through on the CNC with a very thin bit. And they go almost all the way through the plywood, but not quite. And then after I fit them into like the front and the back, I filled in the spaces with like sawdust and wood glue.
Can you show us the other side just to see that it's continuous?
Yeah, sure.
So see how it's like that's a smooth curve where there's like a little bit of layering, but that's going to look different than a laser cut kerf because it doesn't go all the way through.
And so like this is the back, and then this is what I'll like screw onto the drawer front. So and so yeah, it was pretty cool to do. It was very satisfying to like get it to bend into like the, you know, get it to bend along a curve that I had decided on.
Yeah. Kerf bending is just, it's like everybody should try it because it just feels amazing when it works. It's totally like a weird thing that you think is weird, that you have no interest in until you do it, and then boom, it's magical. All right. Anybody wanna, let's see. Anybody want to share? Who's next up? Lila? Yeah, you want to go? It sounded like you knew exactly what Ada's problem was.
Yeah, it happened to me, and I was sitting at the laser. I think that was the first day I met you, Corey.
Oh yeah.
And I was like ready to leave MakeHaven, and you and JR came up to me, and I mentioned to JR what my problem was, and he was showing me in the driver. It has a resolution where like 1 to 5, and if you don't go right in the middle, it starts stretching it.
Huh.
It's real dumb.
Yeah.
Bizarre.
Yeah.
But
And
what's-
then
How do you set it? What's that process?
it's in the driver. You'll see when you bring it up, it has like a little scale 1 to 5 and a little generic picture, kind of like the picture when you go to orient something landscape and portrait. And you'll see the little dial. It should be right, I think, in the center.
It's right
Right,
on
Kate?
5. Yeah, you want it to be right on 5.
Is this on the machine or in Inkscape?
The
It's
driver in Inkscape for the
Okay.
printer. Yeah.
Okay.
it's a
So-
weird setting.
Yeah.
But Lila,
Um,
sorry, I
that's
derailed.
okay. Yeah.
Thank you.
Can I share my screen? How do I do that? How do I do it? Share screen. Here we go. Oh, give me 1 second. Where'd it go?
You're all good.
Oh, here we go. Yep. All right. Can you see it?
Ooh. Yeah.
So this is just stuff I've made since I've actually started at MakeHaven. Like this is like one of the first things I did. I made little name tags for my coworkers, and this was a cutting board I purchased, and I just made it for my neighbors. This was a little box I made for my friend Audrey, another pun. This was a little sign I made for my friend's daughter, and I spray painted it gold. It looked really cool when it was done. I did not do that. Here's some kerf testing. This was a little lamp I made,
Yeah.
and I guess
Oh,
I started cutting a sticker and it didn't take. I think maybe the needle needs to be changed on it, but I can go back to that.
I would,
And
Yeah.
then-
I would tell you that so every once in a while, a little piece of vinyl will get stuck on the blade. And so you go to take the needle out, like thinking you're going to change it or need to make it longer. And you're just like, oh, it's just a little thing. And I bet
Oh, okay.
because there's often just a little piece gets stuck.
Not think of that.
Are you
And
sure
then-
you didn't create a magical object? That looks amazing.
Which one? The lamp?
Yes, the lamp.
So
Yeah.
the lamp, I bought these little what are those called? The fake tea lights with the batteries in it.
Mhm.
And I just stuck that inside of it. So that's all. It's kind of glowing. I didn't expect it to flicker like that, but
It looks really great.
thanks.
It totally
Yeah,
does.
that's what I want to make this week, Lila. That's
Oh,
exactly what I had in mind.
And then I have to say, like the kerf between like when you go to stick those pieces together, it's like sometimes it'll be perfect and then the other times it won't, like it'll just fall right through. So you have to cheat with a little glue here and there.
Yeah, I
And
feel-
then-
How do you have
Yeah.
them connected? Those pieces, I can't see because it's kind of small.
Okay. So I just
Okay.
kind of made a little indentation. I don't know if you can see in here.
Is it like a tab? Like a-
Yeah, it's just a tab and I just shoved little squares in between it. I don't know.
Oh, okay, I see.
Yeah. There, you can kind of see it there.
Oh wow.
Yeah. That's
That's-
beautiful.
That's
Thank you.
incredibly cool. So do they pivot on that piece? Kind
Yeah,
of?
like it's not perfect, but I
Yeah.
mean, if you wanted to, you could figure out the angle and make the thing so you can
Wow.
shove it in perfectly. But I kind of did it quickly, not to, but it looks all right.
How long does something like this take to make?
I am bad when it comes to estimating time.
I would guess because that's all vector cut that it's going to be shorter than you think. Like
It
I would
is
say
shorter than you
probably
think. Yeah.
15 minutes cut time total. If it does it effectively in one pass.
Yeah.
For each piece?
No, I would say total probably.
Oh, wow. Okay.
I felt like that took like a good 45 minutes to cut all of those pieces out, but maybe I didn't have the things set up and maybe
no,
I don't know.
You're probably right. I mean, I was just guessing.
Yeah.
Vectors are usually faster. I love the Merry COVID mist that you did. It was like what I was thinking about when I was saying anti-stencil. Because
yeah, I was thinking because how the script letters, they're easy to work with, and things like you said, they just pop out.
Yeah, all of the islands that left are exactly what you wanted to have leave, and what you've got left over is all connected so that they don't fall apart when they're laser cut.
Yes.
Yeah.
And just for fun, I had bought these notebooks a while ago, so they were kind of in bad shape, but I wanted to kind of try what this looked like. So I put my logo on here today, just for fun. That's all.
It looks great.
Thank you. All right, I'm out. Oh, and I've been working on my website, but I've had some issues, so I know I need a big update. I feel like I'm a slacker when it comes to that. So
It's hard to keep all that in mind. It takes a lot of effort.
yeah. All right, next.
You're all good. You're still screen sharing.
All right, how do I get out of this thing?
There's like a little red thing somewhere.
Somewhere, escape. Oh, here we go. Stop share. All right.
Cool. Yeah. And I'll be at MakeHaven a bunch. So if you need anything, just let me know. If you have a specific time you want to go over, like how to do any of those things, if you want to talk about website or Arduino, whatever, I'm in. All right. Ruby, Kate, Aaron, anybody want to go?
You want to go, Ruby?
Oh, no, you go.
Okay. I can talk about what I did this week, which is just a little bit different because let me see if I can screen share. Whoop. I'm gonna do that. Really? All those options? Let's see. I think this might work. Okay, are you seeing my screen?
Yeah.
Okay. So because I've used the because I've used the laser and the vinyl cutter and the Waterjet a bit in the past, I decided to use this time to kind of focus in on the 2D design goals that I've been totally putting off for a while. So my goals were I was going to cut something on the Epilogue laser because I always use the universals and the Epilogue laser scared me for some reason, just unfamiliar and CorelDRAW and all that. And then I also wanted to try out the Inkscape extension Ink Stitch. And by wanted to, I would say I wanted it to work. I have been kind of dreading it, but so anyway, so I tried the Epilogue. It wasn't nearly as scary as I thought. So good news, especially if you use the universal. There's a lot fewer settings, which, anyway, I had some problems. So a lot of this is the various problems that I've had. I was messaging Corey about CorelDRAW from the space, like what is going on? The video that we have for this needs to be updated. And so this is going to give me some good info for how to update things. But this is, in the end, I did get some stuff. I did get, some cutting happened, and I learned a lot about the laser, the fact that it's different wattage laser and using a different program. So I was able to use that and feeling more comfortable with that. And then Ink Stitch, I don't know if you guys, I know audio is really low. Sorry, that's loud.
Oh, no, that's totally working for audio.
Can you hear this?
We will not explain the stitch types in general, but only how to create them in Ink Stitch.
Okay, so that's the Inkscape tutorial, just to warn you, from Inkstitch, and I found like it put me to sleep. Like I really got groggy. It was like ASMR kind of stuff. Like I was like, what is happening? So it took a lot to like get through that, honestly, but I did. And then I had all sorts of fun problems here. I think some of them are Mac based. I'm going to try a few other things on some PCs in the space. But then I had to hook this up to a PC. There was cord problems. Third cord, finally found a cord that was working. It was the cord. But eventually, so I was making just the New Haven Wallaby, and you can see that I got it to the machine. It's over here.
Yeah.
And that it did work. I also learned some things about our machine. It definitely, as it goes and it vibrates some of the screws out. So I don't know if that's serviceable or what we need to do, but we'll look at that. So this is when the needle came out. This is when the needle broke in the middle of the piece, and then I finally got it. So it was definitely a lot of learning, but I'm glad that I was able to do that. I want to get a multicolor one next time, but I was getting an error message that I need to figure out. But overall, I felt successful.
Yeah, that's love.
So it was a little something different, but yeah.
That's so great. I really want to play around with Inkstitch some more, and let's pick a day and go after the epilogue to make sure that it works. Because as a Corel, like I'm sure you figured out the settings. Let's make that tutorial. Kate, you want to do that?
Oh yeah, definitely. And I definitely like it's working, and I'm comfortable with that. I just think we need to update like some of the stuff. It says like, oh, go to this template. Well, that template doesn't exist anymore. So we either make a new one, or even better, just tell people how to do it. I realized there's one I didn't show the end of the post, but this is just some other stuff that I've done in the past. So it's just saying like, I have used these machines before. These are some various different kinds of things that I've done.
I love the laser cut shell. The laser is so pretty much any natural material will just sort of like cut in the laser, which is really a lot of fun.
Well, Stephen he was cutting an oyster shell a while ago, and then I realized whenever I go to vacations, I get shells and I don't do anything with them. So I've started putting the names of like Myrtle Beach, like where is this shell from, on lasering on them. But I really love about the lasers like the different things that you can etch and try. And we laser cut a pumpkin one Halloween, and it was awesome. So
that's fun. All right. Before Ruby or Aaron hop in, a couple questions came up. Do you check for kerf every time you make a cut on the laser? I do not. But if I'm trying to get things to slot perfectly, then I'll do that. And you should check it for the material and the settings that you're doing. And it's super easy to do. You just cut a square where you know exactly, like a 1 inch by 1 inch square, and then you measure it with calipers to see how much you've lost. And you can do that thinking about either how much you've lost, like if it's a hole, how much bigger is it? Or if it's a square, like the island that fell out, how much smaller is it than it should be, to figure out what your kerf is. And so that'll tell you how you need to add or remove to your design.
Thanks.
Yeah, and then Lila asked, why would you choose the epilogue versus the universal? There's never a line for the epilogue. That's why you choose it. Otherwise, I don't know. The other two are great. They work fine.
The epilogue, it has less power, but apparently has better optics.
Yeah.
Is something that I've heard. And so I didn't do it with acrylic, but I've wanted to try more acrylic in there because I heard it has better results, although I've had great results from the other. So that may be one reason. And one reason that I was afraid of it is that there's a whole video on calibration, and that just felt overwhelming to me, but probably not necessary. Don't be afraid. Try the epilogue.
Yeah. I tried it. I cut a rectangle and it wasn't sized right. I knew there was a setting that I needed to figure out. I also needed to leave at the point when I was trying it. So which is never a good time to try something. So take a chance on those guys this week. All right, Ruby, Aaron, either you want to go?
You want to go first, Ruby?
Yeah, I'll go.
Sure.
I made some coasters. And I'm going to share my screen. I do know how to do this. Hold on. Oh, and then I meant to show this, I think last class or something, but I've made art with the laser cutter. I've made like woodcuts and stuff, and I found some that I'll just show you. This took an insanely long time because I set the quality too high, and it took something crazy like 3 hours because of all these stupid little dots. And then here's another one. And these are just like really tiny dots. So I like learned how to silkscreen around this. This was in February. Isn't that insane? That feels like 10 years ago. Anyways, I was figuring out how to silkscreen around this time, and I just copied those same methods, like the halftone and like, yeah. And like, there's like other like 50% like, what is it, diffuser or something? I don't know. And they translate really well into like to become vectors and things like that. And then this is my friend's actually. Oh,
that's lovely too.
Detail, but yeah, okay.
Those are all super amenable to laser stuff because they're so like crisp.
Yeah, it took a while. It took a while. Let me just put it that way. Okay, I'm going to share my screen. Oh my God.
You're all good. It's the green button. I usually lose it because it's the one that's made to be easy to find.
It's saying, what do I click? Desktop 1?
Yeah.
Okay, my system settings. I don't know what I'm doing.
You're all good. The I'll talk. You stay on task, and let's see. As we're thinking about like what art makes for good like showings, I think there's tons of good examples. And what really was drawn to my attention this week is the difference, because I've mostly been using the laser to like cut things to build. It was highlighted to me in seeing how so many of you use it to make art, how different those processes can be. Like vector art is different from vectors for cutting something, which is also very different from vectors for like, with no intention for visual appeal, just strictly for, I want to make a cut and build it, right? Those are all, they're all handled in Inkscape or Illustrator or whatever, but they're amazingly not the same.
Sorry, it's asking me to change something in my settings, like to give zoom access, but like it doesn't say zoom anywhere.
Y'all good? Should we have Aaron go if you want to keep playing with it?
Yeah, sorry.
Okay.
In the meantime, you guys should all click on the little link I just put in the chat and see a really cool lasered thing that Ruby did that was on our Instagram from back when we could see each other's faces.
Oh yeah, I saw this. This is wonderful.
It is really impressive.
If you click through the picture, you can see the video of it being pulled, which was amazing.
Yeah.
I forgot about that.
Ruby, that is so dynamite. That's,
Yeah.
that's spectacular.
That is amazing.
There was 12 different pieces, and they each took 3 hours in the laser cutter. So I just took up the whole 12 by 18 space to laser, and I used biscuit joints to like glue it together so it wouldn't separate. It was a lot, but
So now that you have like the wood, could you make another one?
yeah,
Cool.
I don't really want to. Right
No. Just like, yeah, I'm sure.
And I'm wondering, like, what if we did it on the CNC? Like, the reason why it took so long is because the laser is such a small piece. Like when we get to this CNC woodblock printing, set the detail that you could get to, but it would perhaps be not take, 40 hours.
40 hours.
Yeah.
That was my initial goal. I was at that point I was pretty like medium level comfortable with the laser. And I was brand new to the Shipoko. But what I guess there's a difference between the CNC and the smaller Shipoko, but the detail that I was trying to capture, I needed a really, really smaller bit, and it would have taken, I guess, about the same or more. But I also wouldn't, like, I wasn't comfortable enough to even start there, So that's why I didn't. I wish I could, but I don't know. I don't know with that level of detail.
Yeah, we'll have to explore that when we get there. But Aaron, you want to let's have you share.
Sure. So I have had a deep desire for a long time to make my own logo. It's like something I've always wanted to do. And I've had an idea, but what I think is interesting about this week is that like I'm a technical person, I can be a creative person, I can fuse those things together, but I suck at this. Like this is very, very difficult for me. For some reason. But I'm trying to like find those moments where you're like, whoa, this is actually really cool, just to sort of help propel me through. So what I've wanted to make in terms of an icon is basically like a light bulb, but with a database icon, like these 3 stacked discs, because my whole job is to really like allow people to better understand the narrative elements of data and to be able to like tune into it. So I started playing around in Inkscape. And initially I was like, okay, I have like a bulb thing and like a set of disc platters for this icon thing that I'm trying to do something like this. And I followed Corey's video, and after watching it so many times, it was like one of those videos that has like a free classical music song that you end up listening to over and over again and slowly going a little insane. But it was incredibly valuable for like understanding the parts, but not like what to click to get things to happen, but not really like to necessarily understand what it means. So things got a little interesting once I realized like, okay, I made this extra section for the like the threads of the light bulb, but realized, okay, once I'd actually made my little symbol here, that I didn't actually need this anymore. And this is where I got really excited. Like, I can't believe I'm saying this, but I've never gotten so excited over something so simple. At least it's been a while. But like, I just created a series of like essentially 2 ovals on top of each other, one white and one black. And then that's how I created this. And that was sort of the challenge for me, is like, how do I make things with like layers of shapes and colors to make something like that. And basically I then just started like harkening back to the PowerPoint that we had last week, just messing around with some of the different types of combinations that we could use. I was experimenting with these and seeing what I could do. So I like this idea of like almost seeing like the inside of a band and it being a different color, but I couldn't figure out how to like smooth out or clear out the edges here. So I still have to like figure that out if that's something that I want to do. And I think that might be something that's kind of cool, because then I could, I don't know, maybe add something on the inside of this band. And I started playing around with colors, and I tried a bunch of different things without really quite understanding what they were. But I think what I need to understand now are just like how this layering works, what these different terms mean, what effect that they have on one another. So I think I'll probably try to find a video that can guide me through that in Inkscape. But in general, I had a lot of fun. This actually took me at least a few hours to sort of puzzle my way through this, but I look forward to maybe getting a little bit more savvy. So that's about as far as I got. Definitely room for improvement, but you know, I'm excited to learn some more.
Yeah, it's a good I feel like vector software is such a weird design space. It's not nearly, you know, in art class for kids, you're taught how to sketch or you're taught how to draw. And at least from my experience as a kid, this was never a thing that they had an explicit lesson on. And so it's neat to like start to get to think about things in this way, but it can feel like a very foreign way to design. And I'm sure there's a couple of you that are probably complete natives to this, that could run circles around the rest of us.
I'm sure. I'm
But
sure.
it's fascinating to see how these pieces all come together, and those booleans for shapes. Like I feel like I've just started to, since moving to New Haven, started to learn what the booleans for designs can really do, and like how that would fit in with shapes and designs. It's such a cool process. And so keep playing with it. You'll eventually get to a logo that you like.
Yeah, that's the plan, and I'm sure I will, and that'll only help propel me into the next thing. So I
Because
think
once
it's also been like electronics too was something I had some trouble with. So like I think there's like a larger strategic lesson that I've taken, and that is that like I can run into things that I like and think are cool, but if it takes me a while to sort of get into the groove of one thing and then go into another difficult thing, I need to plan how to like manage that a little bit better. Like almost like checkpointing, like how can I pick this up in a week and a half and pick it back up? And the answer is like actually using my website and documenting everything, I feel like. Yeah, anyway, I have a couple of fun ideas for next electronic projects I want to do, but other than that, you know, one thing at a time.
Cool. Yeah. Yeah. It takes a while to like cruise into the mode where you can hop between. And then the more documentation, the more comments you write, the more pictures you've taken, the easier it is to keep all of those plates juggling.
While learning a new program. So I thought that's pretty cool that you came up with a logo that you really dig while learning a new program, which is never easy. So
yeah.
There's so many options too. Like I kind of wish that like a program would be like, you can do 3 things. And like as you do them, it unlocks other parts of things. Like I feel like if they had a hey, you're new to this mode to everything, that would be the best thing ever. I could like step through a lot of these things, but that's a lot. There's a lot of options in there. So
yeah.
I need Clippy. I do. I want a Clippy.
Yeah. What a comforting little character.
That's funny. Awesome. Like a video game. Yeah.
Yeah. I feel like all of those Boolean tasks with the shapes, like even if everything else in Inkscape disappeared, those Booleans, if you just had drawing for shapes and the Booleans, you could do a lot. Aligning and all that is really helpful. Like snapping it to centers and those things. Mostly when I'm watching those tutorial videos, I'm like waiting until I see a little nugget of like, oh, that's how you're supposed to align them. Or like, that's how you use the Boolean tool and not be a moron, which is a thing which I should use a different word. But that I get myself backed into weird corners and like looking at examples of videos that people have made. Those are all those let me see sort of how they're doing it. Just like when I watch a woodworker, I get to see how the table saw gets used. It's the same sort of observational learning, but the Microsoft paperclip is totally the way to go. That's the best way to learn. Ruby, you want to try?
I did figure it out today.
Yeah.
Just not a pro at Zoom. I'm a Zoom grandma.
No. You're good.
Okay. Let's not look at that. Okay, here we go. So this is one of the laser cut coasters that I made on maple wood. I had to simplify the design a little bit because I don't know what I was trying to do. I've never needed to deal with this issue, but it doesn't make sense as to why I haven't needed to deal with this issue. And the issue is that I had two vector files that I wanted to, raster, but I put them on top of each other. And in the beta version of Inkscape, which is what I have because I have a Mac, there's an eraser option, which allows you to erase part of the file, part of the vector. So it won't etch, or it won't be readable to, when you send it over to raster. But when I sent it over, I put it in the file bucket and uploaded it. It didn't like that and would forget, or it wouldn't forget completely, but part of the line would go through the character. And it was kind of ugly. So I had to scrap that. And as I was trying to figure it out, it was just too late into the night. And so I ended up just screenshotting it the way that I wanted it to be, and then re-uploading it like a little dummy onto Inkscape. And my issue was fixed there, but it wasn't the best solution. So my question is, if anybody knows, because I don't, is if you have a closed vector, shape, for example, like this circle here, or this kind of triangle, if I wanted to open that instead of having it closed, how do I do that? I wasn't able to figure it out then. And yeah, but this was that. And then
because the Smash Brothers symbol is 4 sections, right? And there's the one section that's completely hidden by the guy. You were saying that was cutting into him.
Yeah, so there's that tiny little triangle that pops out, and then there's the other one that sits behind his head, and for whatever reason it would still cut through, even though I erased it with the tool or whatever.
Oh yeah. You could do a front minus back with the guy, and then and that's one of the tools that I really like on Inkscape. And I love that name for it because it's just so clear, where everything, if the guy is grouped as one object and then the Smash Brothers logo is behind him, and you do front or back minus front, so that the Smash Brothers logo has cut out of it the shape of the guy, it'll probably make the guy disappear. But if you have copied him and then you paste him right back in, you should be able to plop him in and it will have cut him away. It's one of the Boolean maneuvers.
Yeah.
But it's wonky. Hopefully
okay. Thank you. That
can anyone, sorry to interrupt, can anyone share videos on the Boolean maneuvers within this?
Yeah, I'll find some. Keep going, Ruby.
Okay. So everything else I used red oak wood that I actually bought from MakeHaven. It was $5 for, what was it, something crazy, 6 feet of wood.
Whoa.
Insane. I highly recommend you check out their selection. There's red oak, and then there's some more expensive wood. Well, by expensive I mean $20. But yeah, it's beautiful. Look at it. So I just laser etched some flowers that I totally ripped from online. These are not my drawings. I found them online, and I searched up pretty much PNGs, clip art, line drawing, and for the flowers on the bottom, I searched up flower, seamless, and then whatever flower it is that you want. The flower all the way to the right didn't really etch. I'm not really totally happy with how it etched. I think that was just because it wasn't as good of quality, but I'm sure if there was a way, if I spent more time playing with the settings and the edge detection and brightness when you're translating a JPEG or a PNG into a bitmap, it would have gone better. Oops, what's that? And some close-ups.
Now did you raster? Sorry,
Yeah.
Did you raster those or were they cut along vector lines?
So half of these are vector cuts as rasters, and the other are like just actual raster. And I think you can tell which are which, because when it's set to raster, no, sorry, vector cut, the lines are actually kind of thinner. Oh,
Mhm.
yeah. So the sunflower here. Yeah. Versus like these forget-me-nots. So I think these bottom three are actually, yeah, these bottom three are actually set to vector cut. But when you send it all as a raster. So am I making sense? So like there's like the fill,
Mhm.
and then there's the stroke. So the
Yeah.
bottom are all stroke.
Gotcha.
So
And so it would raster a stroke, so it was smaller. Whereas like up here, these were line drawings, and so it was really an infill, even though it kind of looks like a line.
So the bottom, think of it as like the outline of the actual piece. So if you look
Gotcha.
here on the marigolds, can kind of see. Oh, I can. Yeah. So, and that's why like this negative space wasn't etched in.
Gotcha.
I think that's it.
So I don't completely understand what you mean by sending it as a raster, but printing it as a vector.
Yeah. So sending it, when you export it, you are telling the computer based off of
I've
the
got to
color,
go, guys. Good night.
Good night.
based on the color.
Mhm.
So everything in your document is red or blue or whatever color you
Right.
choose. And within that, you can decide individually what is going to be defined by a fill or what is going to be defined by a stroke. And when you export it, you are telling the computer, okay, anything that's red is going to be rastered. It's going to be etched.
Right.
Don't cut it. Even though you set something to a cut, which is just literally the outline of the actual vector itself.
Mhm.
So yeah, you have the option to do the outline versus do the fill inside. Does that make sense?
Totally. So yeah, I guess I had a little issue with that. Like I had to turn everything to vector because otherwise it just burned through it. And so I'm wondering if that had to do with just having too many nodes. And if that actually those are sunflowers, right?
Yeah.
If the middle part is rastered and just the petals are vectored, like how did you do that? How is that set up?
So everything was set to a vector cut. Let me see. Let me just start from the beginning. So let's say this was all red in Inkscape.
Mhm.
I set it in under the section fill and stroke. I set it to the vector stroke, and I set it to 0.002. After that, I go to export, and then I set the red. I tell the computer the red is to raster. So it's just going to raster the outline.
Oh, okay. All
Um,
right.
so it
All
doesn't
right.
matter, like, even if it's set, even if your Inkscape settings say to cut, because it's just defining what it is exactly that is going to be sent to the what information is going to be sent to the computer.
Okay.
An entire fill or an entire outline.
Okay. So
interesting.
the fill for that, you just had no fill. You just set the stroke.
Yeah,
And then
that's
cool.
right.
I'm gonna try that. Thank you.
Yeah. I'm gonna stop sharing.
Yeah, it's the subtlety, and that's something that I feel like is I feel like I just learned something. There's the subtlety of how exactly the relationship between the laser and its driver and the software works is something that you've got to work out, like how well do you understand it for the uses that you're doing. And I just like what I just learned is that when you tell it I want a raster, even if it should be a vector line, it'll raster it for you. Whereas in the last laser I was used to, and maybe for the Epilogue and Corel this wouldn't be true, because I was used to a different Epilogue and Corel. If I had done that in my old laser, I know it wouldn't have cut it. So it's like an interesting little subtlety in the printer drivers that is useful if you know it and can leverage it. That just comes from having, 400 hours of cutting on the laser.
So when do we use the raster vector option on the Inkscape? Is that what?
In my mind, that would be for if you wanted to, like prior to just now, with what I just learned, I would have thought that would have been, I have a red square with a red border, with a red fill and a red stroke. If I wanted to have it raster vector cut everything red, it would raster the inside and then it would vector cut the outside. And so you could get it to do the same settings for red as a raster and as a vector, which is sort of it feels like an odd scenario. That's the setting used for the logo, is the raster vector setting. And it seemed like it worked great. Did you have a infill and a stroke?
No stroke. It was all just fill. It was set as a vector. This is where I get confused, because I was thinking, do I turn it into something? Because I kind of just wanted it to be burned, like an image on it, and depending how. Do I need to turn it into a picture? But it worked. So that's the setting I go for when I want to do that kind of effect, when I want it to be kind of like an image, but it is a vector.
And so my question is, did it do when it's rastering on the laser, it goes back and forth and back and forth and back and forth. And so it did that, but then did it also follow the border of the whole thing afterwards?
No.
Gotcha. Because in my mind, the vector procedure is when the laser runs in like the weird shape of your design. And
yeah, that's why I just I select that, and I'm not really sure what it does, but I feel like that's what I'm taking a vector, and I wanted it to be cut as a raster in a way.
Yeah, I think that raster would do it. In my mind, raster should have only handled infills, period. End of sentence. But
and it is a
Ruby,
fill.
Oh yeah, no, and so like I'm 100% with you.
Yeah.
The raster vector, in my mind, it would have made sense for yours, because then the vector may not have had anything, like the stroke may not have been anything, and so then it wouldn't do that.
Right.
This is like where, and I bet it's different for the Epilogue in the space, like the next laser over. I'm sure it's not identical. So
it's getting late, but if we have time, I would love to see Wilgara's electronics, if that's
oh yeah.
Oh, just for the sake of time, I mean, I don't want to hold I'll post it on whichever.
If you got it nearby, hold it up, let's see it.
Okay, so this is a soil sensor. So this is something I purchased through SparkFun. And so there was software available on GitHub. You could download and plug into the Arduino. I reprogrammed it a bit to be more like a stoplight sensor. So based on how much moisture there is in a plant, it would change to one of these colors. So this yellow line, it's an analog. And so it just produces like some arbitrary serial numbers. And so I just have that changing colors on the LED based on whatever those values are. So I have a plant here. So It may not. Let's see.
I love that you got the plant ready. You staged this.
Well,
legato.
I took a little break to grab it. Let's see if I have the battery here. So okay. Wish I had some extra hands. Okay, so you see now I plugged in the battery and it's red. And so it's measuring like 0.
Oh yeah.
Some arbitrary value. So I'm gonna stick it into the plant. And so, so I don't know if you could see it.
It was green. It's green. That means that it's good.
That means that it's good. Yeah.
That's awesome.
So yeah, it's kind of flashing right now, but yeah, I was trying to get it to work with this AVR chip, but I was having a lot of issues with the C++ programming. Like, I don't know, or the C programming onto this thing. I don't know what was going on.
Yeah, you'd want to, it's probably the pinouts would be my guess, because the pins are going to be different on that than they would be on an Arduino.
Okay.
But it'd be good to take a look and see sort of what kind of chip it is, and it should be able to work on one of those chips, so you could make it the whole thing really tiny.
Oh, that's great.
Yeah. So.
Did you find that it was accurate? That it could give you numbers that were like, we're just seeing the light, but I know you have a readout on the computer. And did you find that did you have any other sensors to compare it to, or ways to see how well it was working?
Yeah, so it's kind of nice. On the top right of the Arduino programmer, there's this little serial output that can either graph it or produce numbers based on whatever the connection is. So I compared it to that. And so what I did, I mean, I think it was going up to like 800. I don't know what that means. It's like, that's like the highest number it was reaching. That was when water was poured into there. And if it was completely dry, then it was like 0. So I just set like, I don't know, like 650 is a green light. Like 450 to 650 was a blue one. And was it the other way around? Yeah. So
sure, it sounds right.
Yeah, yeah.
So,
And then 0 to whatever that lower limit was is the red. So
did you take the code from SparkFun, or did you? I'm just curious if they have like more information, or like like a sheet, like an info sheet on what some of those numbers can mean, and if there's any equations you can throw in there to get like very specific
information,
measurements. Yeah.
Yeah.
So that like that an 800 has like real meaning to it.
Yeah, I think it was just arbitrary to like whatever you zeroized to. I was looking for some additional information. They got some data sheets and stuff like that, just some hookups that you can plug into here, but I wasn't able to find any more information with regards to that. So
Yeah.
I just put in the lights in there to help me remind me to water the plants, because it gets pretty dry in here. So
is that just like a moisture sensor, or does it have like because you said it's a soil sensor, did they throw in other things like
it's
nutrients in the soil and things like that?
Yeah, it's just a moisture sensor. So I mean, you can take the same thing and dip it in water, and then you can see like the serial numbers shoot up on there too. So
yeah, I think that they're conductivity based, and like essentially however much it conducts electricity between the two prongs, it will give you back a higher number. And so it's probably just ranging in the analog range of 0 to 5 volts. So you get 0 to 1023. And even though like you might get a calibration curve from SparkFun if they've done some real testing, and you're welcome. Anyone could do that testing if they wanted to, but usually the relative numbers are really helpful. So like that, it may not be, and sometimes the relative numbers are all you really get. Like measuring light is actually really hard. In lumens, to measure the correct amount of lumens of something is not an easy task, but it's super easy to install a light sensor. And so just, is it brighter or is it darker, is often really helpful.
Yeah, so yeah, I'll try to get some details whenever I get around to updating my website. Kind of
But
like
it's
a little bit of the
functional.
background. Yeah, well,
It's doing what you need it to do. So
That's awesome. Yeah, people have really done some awesome stuff this week. It's been really cool to see what happens. It's fun. It's fun to see how the pieces, especially when we get like a double presentation from Wagata. That's neat. And I'm excited to see what happens this week. It's 9:12. We should probably get going. It's getting late, but it's exciting. And hopefully I'll see some of you in the space this week. If you, I really have nothing to do. And so if you want to chat and work on stuff, I'm in at any point. Just reach out. I'm happy to help. So